Assalamu alaikum, this is Sir Pasha, and our today's topic of discussion is Newton's third law of motion. Alright, now this is one of the most important, one of the most significant laws in physics. I mean, you just take out this law from physics and all of the classical physics or the Newtonian mechanics will, it will fall down. So this is very important, and unfortunately, very unfortunately, a lot of candidates do not have the right idea of what this law actually means, because the statement is so simple that everyone remembers it. So today's discussion, I will not be focusing on the statement, rather the actual meaning and how it can be used in different examples of physics. But before I actually move on towards third law of motion, let me give you a quick recall of what was first law of motion. First law of motion was every mass will stay at rest or in a state of motion, uniform motion, until or unless it is acted upon by an external unbalanced force. So an object at rest will remain in rest, and an object in motion will continue its uniform motion with constant velocity unless it is acted upon by a force or a resultant force. Then we moved on to our second law of motion, which is that whenever a mass is exerted upon by a force, it will experience some acceleration, and that acceleration will be in the direction of the force. And ultimately, the greater the force, the greater the acceleration, the lesser the force, the lesser the acceleration. So the acceleration is directly proportional to the applied force or the resultant force, and the acceleration is inversely proportional to the mass of the object. And then we also saw that this is one way of explaining Newton's second law of motion in when we are dealing with very basic physics. But obviously, as we move on, we have to realize that Newton's third law of motion is even broader in its meaning, and that actually is that the resultant force acting on a mass is actually equal to the rate of change of momentum. So the greater the force, the greater will be the rate of change of momentum, and vice versa. But this Newton's third law of motion has a very simple statement, but with very deep meanings. So here we go. This is where it starts. All right. To every action there is an equal and opposite reaction. Or in some books you will say, every action is an equal and opposite reaction. Now this is often wrongly interpreted. You have to have the idea of what this law actually means. So first of all, you need to understand what this action and reaction mean. All right. Obviously, this action reaction is not like you slap someone and then the person will slap you back. Obviously, this is not what Newton was trying to say. Otherwise, if I slap someone and I run away, probably I'll be violating Newton's third law of motion. And I hope this is actually not true. So we need to go into the deep meaning of what actually Newton's third law of motion is. So first of all, this action and reaction means nothing but force. So first of all, this action refers to as the force, and this reaction refers to as force. This same law can also be written in a different way and in a more understandable meaning as. Now this is a better explanation of Newton's third law of motion. It says when a mass exerts a force on the other mass exerts a force on the first mass, which is equal in magnitude but opposite in direction. Now let me give you an example. This is the wall here. If I exert some force on it, I also feel some pain. Now what actually happens here is I have a system of two bodies, right? This wall and my hand. So when my hand hits the wall, it exerts a force on the wall, and then what happens? The wall exerts the same force on my hand. This is why I also feel some pain. So if I hit it harder, I will also experience a harder force. So what actually happens is whenever two masses interact, when I say interact, I mean whenever a mass exerts a force on the other mass will exert the same force on the first mass, which is equal in magnitude but opposite in direction. Now let me give you some examples, and then we'll go on to the further details of this law. If you have a glass, do one thing. hit that glass on the wall, what will happen? The glass will break. I'm afraid I cannot do it here right now, otherwise, take your mobile phone, hit that on the wall. What will happen? The mobile phone will break. Now what a physicist sees is that when I hit this mobile on the wall, the mobile exerts a force on the wall, and then what happens? The wall exerts the same force on the mobile. So these are a system of two bodies, the mobile and the wall. The mobile exerts a force on the wall, and it couldn't affect the wall, but in response the wall exerts the same force on the mobile, and that breaks the mobile, because this cannot withstand a lot of force. It has to break. It has glass and plastics and all these things. So what actually happens is that the impact can be different. Now look at the example. If I slap someone on his mouth, let's say this is the mouth of someone, and I slap it on his face, what happens is that this is a system of two bodies, my hand and someone's face. My hand exerts a force on someone's face, the face also exerts the same force on my hand. The impact is different. Probably the person will be crying and I will not be. It is not because the forces were different, the forces were same, but the impact were different. This is a sensitive skin and this is a rough skin, so the impacts are different, but the amount of force is same. But the direction is different. So first of all, in order to actually observe Newton's third law of motion, you first need to understand the very idea that forces exist in pair. ये जोड़ी बना के रहते हैं. They cannot stay alone. They will always exist in pair. And our today's topic of discussion will have a greater emphasis figuring out the Newton's third law of pair, which we call as action reaction. In some cases, in some books even you would say that the term action reaction is probably not justified to explain the concept of Newton's third law of motion. It is because you may assume that the other force arises as a result of one force. That it means that there has to be an order, that when one force happens, the other force exists. This is not the case. What actually happens here is that they both exist simultaneously. The moment I exert a force on this object will exert the same force on my hand, and it would be unfair to say that this force existed first and this started. They both exist simultaneously, so that is why they are called as Newton's third law pair. And in a lot of books you will rarely see the action reaction pair. So what they look at is that is the term that is the Newton's third law pair. And now let us try to figure out that where these Newton's third law of motion, or this Newton's third law pair of forces can be observed. Alright Ji, so now here I have written 4 important points regarding how the Newton's action reaction pair exists. Alright, so here forces exist in pair and they act on different masses. They are opposite in magnitude, they are opposite in direction, they are equal in magnitude, they are opposite in direction, and they are the forces of the same type. Now this is very important to understand, that they are the forces of the same type. Now first of all, in order to observe Newton's third law pair, you need to have two masses, obviously, that will interact with each other. Now try to understand, what does this "they are the forces of the same type" mean? To understand this, we need to understand how the forces interact, how masses interact with each other. Now forces exist in pair. So these are the 4 important assumptions, these are the 4 important things that you need to remember while figuring out the Newton's third law action reaction pair, or Newton's third law pair. And for that, first is that they act on different masses, and this is why a lot of you, even at your age, when I was studying O-level physics, A-level physics, I used to ask my teacher that if these two forces are equal in magnitude but opposite in direction, then they must cancel out each other. So it means that there will be no effect ever. This is wrong. Why? First we need to understand that these two forces act on two different objects. Alright, see, this is a mass. Alright, this is a mass. If there is a force acting on it from this direction and then there is another force acting from this direction, they are equal in magnitude, opposite in direction, for sure they will cancel out each other. But if what happens is I have, for example, two masses like this. These are the two masses that I have. On one mass there is a force of 100 Newton acting in this direction, and on the other mass there is a force of 100 Newton acting in this direction. There is no point that they will cancel out each other. It makes sense. They must not cancel out each other because these two forces are not on the same object. So action reaction can never cancel out each other. Why? Because very important that they act on different masses. And then we have just discussed that they're equal in magnitude and they're opposite in direction. Now the next thing is very important. You have to spend all of your money here. They are the forces of the same type. Now what does it mean to say that they are the forces of the same type? To understand this, you need to first understand how masses interact with each other and how these forces actually get produced. For example, there is a force called gravitational force. Every mass in the universe attract each other through a force which is called the gravitational force. So if action is a gravitational force, then the reaction has to be a gravitational force, because action reaction pair has to be, or the Newton's third law pair has to be of the same nature, have to be of the same type. For example, a mass comes in contact with the other mass. The mass exerts a contact force on the other mass. The other mass will also exert a contact force on the first mass. So the contact force is a type, and action reaction pair or third law pair has to be, if one is contact force, the other has to be a contact force. If one is a gravitational force, the other has to be a gravitational force. Similarly, two charged particles are attracted or repelled. So when one charged particle exerts a force on the other particle, the other also exerts the same force on the first particle. That is electrostatic force, or that is electric force. So you need to understand that these forces have to be of the same type or have to be of the same nature. So to clear this, there is one very good example that I need to make you understand. First, let me explain you with very simple example. Let's say I have a positively charged particle here and I have another negatively charged particle here. Now what will happen is that, let's say this is a positively charged particle A and this is a negatively charged particle which is B. What will happen is that since they have opposite charges, we all know that unlike charges attract each other, this positive charge will attract this negative charge towards itself. So I will say, alright, there is a force acting on negative charge, but this force is acting on negative charge by positive charge. So this is F, that is electrostatic force on B by A. Here again a same force of equal magnitude but in opposite direction. So that will be force on A by B. So you see, these are the electrostatic force. That makes sense. That is electric force. And if you know Coulomb's law, you would better understand that why two charges attract each other. And the next important thing, if, for example, I have the example of Earth and Sun. These are the two masses, and what happens is that the Earth attracts Sun towards its center and Sun attracts Earth towards its center. That is how the forces act. Again, these are the gravitational forces that are acting in opposite direction, but they are equal in magnitude. This can also be understood with the example that let's say this is earth and let's say this is a man in the air falling down. What happens is, why the man is accelerating down? It is because there is a force acting on it by the earth. This is a gravitational force. But always remember, this man is also attracting the earth towards it through the gravitational force. In 8th level physics, you will study that in deep, but please try to understand that this is the action-reaction pair. This is the Newton's third law of pair. That this is the gravitational force and this is also the gravitational force. Equal in magnitude, opposite in direction. But because Earth has a massive mass, so that is why you see a very small acceleration in Earth. That is why you actually doesn't see the Earth coming up, but you do see the man going down, because you know, for a man of this size, the force is sufficient enough to produce a healthy amount of acceleration. But on a mass like Earth, the same force won't accelerate it. For example, I have a wall like this, and what happens is that I hit it with a ball. What happens here is that when the ball comes in contact with the ball exerts a force on the wall. So this is force on wall. What will happen at the same time, at the same instant, because action reaction exists simultaneously, the wall will exert the same force on the ball. Now this is that these two pairs have the same type electric forces. These two pairs have the same type gravitational forces. These two pairs at the same time, what? The gravitational forces. But here, these are the contact forces. You cannot have Newton's third law pair such that one force is a contact force and the other force is a gravitational force. So, an example that has often been asked in exam. You see, this is the surface of Earth, and on this surface I have a mass placed. Alright? So there is a mass placed on the surface of the Earth. What happens is that this mass has two forces acting on it. Its weight acting down and the normal reaction acting up. Since this mass is at rest, I would say that this normal reaction and weight have cancelled out each other. So I would write here as the normal reaction, and I would write this force as its weight, which is the gravitational force. Now my question is that are these two forces, the normal reaction and the weight, are these two forces the action-reaction pair? Are these two forces the Newton's third law pair? The answer is no. They can never be action-reaction. They can never be Newton's third law pair. Why? Though they are equal in magnitude but opposite in direction, they are satisfying these two conditions, but they are not satisfying these two conditions. This condition, they act on different masses. You see, normal reaction and weight, they both are acting on the same mass, which is this mass, the box placed on the surface of the Earth. So if two forces, no matter they are equal in magnitude, opposite in direction, but if they are acting on the same mass, they can never be Newton's third law pair. Then the second reason, that these two forces must be of the same type. Are they of the same type? The answer is no. Normal reaction is a contact force. Weight is a gravitational force. So they are not of the same type. So this means these two are not the action reaction pair. Now you would say, sir, then how can we explain the action reaction pair here? Do we have an action reaction pair? Yes, we have. We will always have. But we will have to be smart enough to figure it out. We will have to go into the depth a little. Now hold on. What actually happens here is that this weight, which is the gravitational force on box, this is acting downward. This is the gravitational force exerted by Earth on the box. Always remember, there will always be an upward force. That will also be a gravitational force, because it's not just the Earth that is attracting us, it is we that are also attracting the Earth. So it is not just this mass which is being attracted by the Earth, it is the Earth that is also being attracted by the mass. So if, for example, the Earth is exerting a force of 500 Newton on this mass, this mass is also exerting a force of 500 Newton on Earth, which is the gravitational force, but in the upward direction. So I will write this is also the gravitational force on Earth. Now these two forces, the weight, the gravitational force on the Earth and the gravitational force on the box, in opposite direction, acting on different bodies, equal in magnitude, opposite in direction, same type, yes, they are the action reaction pair. They are the Newton's third law pair. What about this normal reaction? Always remember, when this box comes in contact with the surface of the Earth, it compresses the molecules of the surface of the Earth, and then there is a force that is generated which is called the contact force. And this force is not only exerted on this mass, but what actually happens is that there is a contact force on Earth by the mass. Now please remember that these two forces are the third law pair. And these two forces are the third law pair. Again, this is also a contact force, this is a contact force. You see, when the mass comes in contact with the surface of the Earth, it exerts a contact force on the surface of the Earth, and then the surface of the Earth also exerts a contact force on this mass. Now these two contact force, which you call as normal reaction, they both are contact force, they are acting on different bodies. One is mass, this box, and the other is Earth. They are equal in magnitude, opposite in direction. Yes, they are the Newton's third law pair. These two are the Newton's third law pair, but these two forces, normal reaction and weight, they are not the Newton's third law pair. So always remember, Newton's third law of motion is a reality, but you have to actually understand that what this reality is. It's not as simple as I'm eating something that something will eat me later. Obviously, action reaction doesn't mean this. It means forces, and not just forces. It has its own conditions. And in order to be good in physics, this is very important to understand the mechanics. So these are the basic examples that I could have given. If you have gone through this lecture with good concentration, you will find that past paper questions will be easy for you to understand. And more importantly, there are a lot of questions that you will be able to solve. Thank you very much. It was nice.